So I'm just going to do a quick run through of my code because I noticed that you guys only want the PDF with links to videos. You don't want to actually see the code itself. So I figured I'd just do a little video of it. So this is the game server file. You've got the main here, which will start off by reseeding the random number generator, and then it sets up a string with the location and the name of the Prolog wrapper process. Which you can give as a command line argument as well. But if you just run it from the package it generates in Devil, the folder it generates, then that's the name of it there. Sets up some service callback functions. So you've got your player turn ping service, which the client can ping this service and it gets back both the current turn, like whose turn it is right now, as well as the current chain ends. Then you've got the player hand service, which when the process is launched, it will query the server through this service, and they'll get back their 7 tiles for their starting hand. And that also lets the server know that the player has joined, which allows it to increment a variable called players joined, and then when the minimum amount of players have joined, the game will start. The player move service is when the player actually plays a tile. So they find a tile they want to play, then they send this request to the player move service, which the server then verifies and throws through and updates everything on the server side, updates all the belief based on the new public information. So it can do belief revision in there. And then you've got the can play service, which is the player on their turn, they will iterate through their hand. And then for each tile in their hand, they'll send a ping to the can play service, and the server will return a 0 if they can play it on the left side of the chain or the low chain, a 1 if they can play it on the high chain, and a 2 if they can play it on either end of the chain. And the player uses that information to work out their options for play. So that's that one, and then you've got and that's also querying Prolog. So I'll talk about all these functions, the callback functions, in a minute when I scroll up. But you've also got the holding chance ping. So this is for part 2. The player can query this service to find out what the chance is. Well, it doesn't give like a actual chance. It uses the chances held in the belief to kind of find a score based on how likely another player is to be holding a tile with a certain value. So the client passes in a target player, which is, for all purposes of this, the next player in the chain. They also pass in a pip value, which this then finds all tiles the target player is likely to have with pips equal to that value. So we'll start off having a look at the player turn ping service because it's very simple. So player turn ping service here. It literally just doesn't do anything with the request. It just sends back a response. Whose turn equals current turn, which is a server-side variable. Chain left equals chain 0. Chain right equals chain 1. I'm not sure if I mentioned that it sends back the current chain, but it does. I just put it in here so that you don't have to have a separate service just for updating the chain. So at the start of a player's turn, they're always going to know the most recent up-to-date chain, which they can use for calculating their plays and stuff. So next we'll look at what do we got? Player hand, player move. So we'll look at player hand. So what it does, the request is hello, which is literally just the player ID, but it's not really used much. It's used a couple of things, but it'd be easy enough to just use current turn that we have on the server anyway. So it starts off initializing this hand two-dimensional array, iterates over for the max hand size, which is just 7, but it's a public variable or a constant, and then it's just going to print out some stuff to the console, and then it calls generate tile, passes in this hand, passes in the index, and passes in the player ID, and then that's just up here. So it's just a recursive function that tries to find a random tile that hasn't yet been generated. So it calls has tile been dealt, which is just another basic function that works out whether the tile you pass in with the left and right has actually been dealt yet, so that players don't get duplicate tiles. And then you've got the established true belief stuff here. So this is just initializing the true belief matrix on the server, which is the absolute belief value, so it's only true or false. There's no uncertainty because the server obviously knows everything that's going on. The player's belief is different from this, and the player's belief actually has uncertainty, and that's all handled in other functions we'll talk about in a minute. So after that, it adds the pip sums, which is just kind of the scoring mechanism. It's not something that's required in the assignment. I just put that in just for fun, I suppose. Then revises the public belief here. So the public belief is the belief that the players have. So it's got uncertainty to it. And again, I'll talk about these functions in a minute, but basically it just passes in the player ID and then the card in their hand, the tile in their hand. And all that's going to do is just ensure that this player who's getting dealt this hand knows that they have a 100% chance of holding all the tiles they've been dealt, and every other player has a 0% chance of holding any of the tiles that this player has been dealt. So then it's just going to, this is messy, but I wasn't 100% sure on the syntax for doing arrays inside of the service. So to avoid having to, mess around with it too much, I've just done it as a bunch of different ones here, which I know is bad practice, but it does the job for right now. So it just sets up all the tiles in hand there to be sent back to the client. Increments players joined, put some console stuff, and then if players joined is greater than or equal to min-max players, which is again just a constant, it's going to start the game. So it initializes the public belief, and it is going to generate the starting chain as well. So that's just a random tile that it starts on, and it sets the current turn to 0, which allows the game to actually start, because the current turn starts at -1. So when players start querying to find if it's their turn, they're going to get -1 and say, oh, the game's paused or the game hasn't started yet. Once it's 0, player 1 can actually start playing. Next, we'll have a look at the can play ping. So this one's a bit more complex. So the can play ping service, you've got two bulls here, can low and can high. So that's if you can play this tile, you give it on the low chain or the high chain. And then can low and can high get set to the returns of these two functions here, which I'll talk about in a sec. But basically it goes if can low and can high, res.where equals 2. So that means it can be played on either. If it's low, it's 1, and if it's high, then if it's low, it's 0, if it's high, it's 1. Then it sends that back to the client. So we'll talk about these functions now. So you've got the can play low ping. Where is that? Yep. So can play low, can play high. They're pretty much the exact same thing, just for different sides of the chain. So you pass in a tile left and right value, and then you've got just setting up the prologue arguments here. So this is going to actually make the prologue call. So what it does, it forks to create a new child process. The child process then goes and opens up a new process of the prologue wrapper, going back to when we initialize in the main function where that actually is and what the name of it is. And it passes in these arguments, which is the C wrapper itself, the name of the atom. So in my case, it's can play on end, and this string is just pretty much that. And then it's C strings for the chain left, the tile left, and the tile right. So then it's going to start that wrapper process, which queries prologue and then returns a value based on that. We'll go through the wrapper in a little bit as well. But that's that there. And then so once the child process, well, first of all, if the child process is less than 0, so there's no response, it's failed. It's going to return false and the fork fails. Otherwise, once the child process resolves, the parent process is going to wait for the child and build a response based on the process ID of the child. So if it's a success, we return true. Otherwise, we return false. Can play high does the exact same thing, except it's passing in the right side of the chain instead of the left side, which is just the low and high. And that's pretty much that. Next, we've got the play move service. So this is once a player actually finds a tile they want to play, which for task 1 is just the first option they have. And for task 2, it uses some belief stuff to find out the best option. but we'll get to that after we go to the player client. So what this is going to do, it's going to make sure it's a legal move. So if the chain end is just used to compare because that's what I use for a player passing or ending the game. So if it's a legal move, it's going to do the public belief revision. So that's again, belief revision for each specific player. So this is new public information once a tile's played. So we update the public and the true belief to reflect that that tile is not going to be in anybody's hand anymore. Modify the pip sums, again, just scoring stuff. Chain index, so we work out what side we're going to put that tile on, what side of the chain. History tile stuff, so this is just all your tile history and your play history getting updated based on the play. And if it's not a legal move, if it's -2, we assume the game's over because the player who was taking this turn has no tiles left, which means that they're obviously the winner. Get rid of that there. And otherwise, the chain, if it's any other negative number, normally just -1, it means the players passed their turn. So then you revise the public belief. Again, the belief of the players, the uncertainty stuff, based on a pass. So what that means is that every other player knows that this player does not have any tiles that have the pip end equal to either side of the chain. So that's a pretty valuable piece of public information there, and you can update your belief based on that. So then we just say the success is 1, so you send that back to the player so they know that the move went through all right, and then it updates the current turn. So if it's 3, which should be max players, sorry, then it's going to set it back to 0. So I set it back to 0 so that it just cycles through the turns, and if it is the maximum player, so the end of the chain of players, it's going to update the current round as well, and then print that to the console so we know what round we're on. Also prints out the new chain and all that stuff. So that's pretty much it for the game server, apart from the belief stuff. So we'll go talk about that now. Up at the top here, so you got the has tile been dealt and all this initialization stuff. It's very self-explanatory, but we'll also talk about the get holding value, the chance holding value. So this is what's used to score with the tile holding ping that the client can ping the server for. So we start off chances equal to 0. We have a pairs scan thing, so we know what pairs we've already scanned, as in pairs being tiles. Then we iterate over all the tiles, and if it hasn't been scanned, we check if the right or left side is equal to the value which we pass in. So this is when a player is checking what the odds are that the next player in the chain has a tile they'd be able to play on the new chain created by their potential move. So that's how they score their moves for task 2. So if R is equal to value or L is equal to value, so right or left side, we find the public belief for this player. So the information they know about this tile, about the player they're looking at. Then we say that tile's been scanned, and then we add that belief to the chance, and we return that. So it's like the sum of the chance of them having the tile you don't want them to have. So this is actually subtracted from the value of an option of play. I talk more about options of play in task 2. It's a little system I wrote so that players can look at all their options and score them based on different factors and then pick the best one. So that's the holding value thing there. We've got the revised public belief in hand. So this is when a player's dealt something. All players, that they know that all other players do not have that tile, and they know that they do have that tile. So that's basically all that's doing there. So 100% chance, 0% chance. Then it revises public belief. Revised public belief pass. So that's going to, again, like I explained before, all the players are going to know that all players are going to know that the player who passed their turn does not have any tiles with ends equal to either side of the chain end. So they had nothing to play. And then again, we revise the public belief here, which again, I'll talk about in a sec. It's just up here. So we revised public belief played. So this is when a player actually plays a tile. So the simplest one, arguably, public beliefs updated for all players, so they know that